This is lesson 11.5, and we are dealing with area of similar figures. Just as a refresher, similar figures, sides are proportional, which means side length over side length equals side length over side length. You're comparing the two figures, and their sides should be proportional, and then your angles are congruent. So just a little background of what we have talked about for similar figures before. So theorem 11.1, if two polygons are similar, then their areas are proportional to the square of the scale factor between them. So what does that mean? If I have two polygons that are similar, I can say that AD over FJ, but I have to square those two sides to have it equal the area of one over the area of the second. So the big thing is when you set up your proportion, just make sure you square both of your side lengths to be able to set it up in the area. If they ever ask you for the scale factor of your figures, create it with the sides. If they ask you for the area scale factor, then you would use your area numbers. But if they don't say area scale factor, just use your side lengths. All right, so what do these types of problems look like? In problem number 1, I know that A, B, C, D is similar to P, Q, R, S. Now remember that when you have this, your order does matter. So notice we have side CD in our first one. That would correspond with side RS in our bigger one. If the area of ABCD is 48 inches squared, I need to find the area of the larger one. So I'm first going to start out with my side length, 6 over 9. And I'm going to square those numbers. So 6 squared and 9 squared. I need to do that so I can use it with my areas. I don't have to do anything to my area numbers. I just have to do it to my side length, because if you notice that inches is just in an inch. So that would be like a 1 dimension. This is in units squared, so this is really asking you to solve for a total area, something like that. So that's why I have to get my units in the same, which is why I would square the side lengths. All right, so after I do that, I'm going to cross multiply. So 6 squared is 36x. Equals 81 times 48. So 81 times 48 would give me 36x is equal to 3888. So divide both sides by 36. So right off the bat, I can get that my area equals 108 inches squared. All right, go ahead and try your next. Check your progress. Here are your answers. Notice I set up side length over side length, but I squared them before I set it up with my areas. All right, so we had two side lengths that were given, and we're missing an area. This time we're given the two areas and we're missing a side length. So triangle ABC's area is 98 inches squared. RST is 50 inches squared. I know they're similar, which means I can set up a proportion. Find the scale factor from ABC. So remember, that's top to bottom. And find the value of x. So we're going to find the value of x first. So remember, I'm going to set up my side lengths, 14 over x, and I'm going to square both of those numbers because they're my side lengths. Then I'm going to set those equal to my areas. So 98 goes with 14, so I'm going to set those both on top. X goes with 50, so I'm going to set those both on bottom. And then I'm just going to cross multiply like normal. That would become 98x squared is equal to 14 squared is 198, or 196, sorry, times 50. So I get 98x squared equals 9800. So now before I square root, I have to get rid of everything by the x squared. So x squared becomes 100. Now I can square root, which gives me x equals 10. All right, so that's my side length that was missing. Now I have to find my scale factor. Now notice it does not say area scale factor. So when it asks for the scale factor of A, B, C, D to RST, I'm going to put A, B, C on top. So I would say 14 over X, which is 10, and I'm going to reduce that to get 7/5. That's my scale factor. All right, if you will stop this video and try your next checkpoint. Here is the work for your check your progress, and my scale factor, I did not write that down, is, let's see, TUV is on top, so 9/6, which would reduce to 3/2. All right, last one, some scale models using the same concepts. The area of one side of the skyscraper is 90,000 square feet. The area of one side of the scale model is 200 square inches. If the skyscraper is 720 feet tall, how tall is the scale model? Now you can convert if you want to, but you also don't have to. So I'm going to use my areas and my sides the same way we have been doing it the past few problems. So my skyscraper, my actual, is going to go on top, and then my model is going to go on bottom. It does not matter in this problem which one goes on top and bottom. That's just how I'm going to keep my lines straight. So my skyscraper is 720 feet over X. I don't know how many, and that's in inches. Remember, you have to square both of those numbers to set equal to my actual skyscraper has 90,000 square feet over my model has 200 square inches. So because I square 720, that also gives me the same units, so I could square my units. So then I'm just going to cross multiply. Now I don't have to convert because notice that inches are on the bottom, inches are on the bottom, so I will end up with inches. That's why I don't have to necessarily convert. So I get 90,000 x squared equals 720 squared, 518, 400 times 200, which is that. All right, so I get 90,000 x squared is equal to a big number. Okay, I'm going to divide both sides by 90,000. So I get x squared is equal to 1152. Then I'm going to square root both sides. So my x is 33.9 inches. So again, the same process, and again, not trying to confuse you when I'm telling you to square here and square here. I'm just kind of explaining why we're doing so. So side squared over side squared is equal to my area over my area. That will work every time consistently. All right, go ahead and stop this video and try your next checkpoint. And here it is. So hopefully you learned something today about some area of similar figures, and look forward to seeing you back next time.